Hello friends, welcome back to the bench. Today we have this beautiful PD1000BA 1 kilowatt power amplifier, audio power amplifier. This one came to me pretty much in pieces, and you'll see that it was basically not properly packaged, and it just suffered a lot of hits during the shipping. And the description of it was that there's something rattles inside and it doesn't work. This was one of the things that was rattling inside, because this is a DVD player as much as an amplifier. It has audio outputs and you can play DVDs on it or CDs. Since I have neither, and I can't imagine who wants to watch DVDs other than your wedding video, I decided not to even touch that. I just removed it, and it works great since then. It's actually not bad. Design concerned, or design wise, it's actually not too bad. There is one big issue with it, but it's made a lot better than the PDA-6BU that I worked on last time. And the reason is that this one is actually made a little better. But as in always in every Pyle design, there is some design flaws which causes a little bit of hiss in the speakers. No big deal, but it is a little bit annoying in certain circumstances. But this shouldn't be a problem for anyone who needs 1 kilowatt amplifier, because the hiss is barely noticeable even if you play at 15-20 volume, right? All right, you want to see what's inside? It's pretty interesting. Let's see. Alrighty, so the monster is open. This is not great. I don't think I'm gonna be able to repair the CD drive, and I don't know if anyone uses these anymore. I sure don't. I do have one in my car, but I don't have any CDs, so I'm just relying on radio. And these, so we have speakers A and B, but these are actually, that's the same line. We just get left, right, and ground, and they go to all these. So, because I was thinking this was like front speaker, back speaker, that kind of thing, but no, it's just regular. You can connect up to 4 speakers, but they'll play the same thing. And one of the relays here, the cover is a little loose, but it should work. I checked all the transistors. The transistors are the same as in our previous guy. Toshiba, what was it? So I can see it right now, but it's the same transistor. Very good, very cheap for its quality or performance. It's actually very good, very good bang for your buck. These transistors, they're also controlled by these, are driven by these. Many parts over here are SMD. There's some chip I haven't identified yet. It's over here. It looks kind of like microprocessor. Next to it is 6 megahertz crystal. So this might be microprocessor. Bluetooth, the same thing. Antenna soldered onto the little Bluetooth module, but at least we have the connector on the output over here, so I can actually buy antenna and connect it to here. So that's not going to be a huge issue. Other than that, I didn't try turning it on. I think I'm going to do it through the light bulb, but I don't expect anything to be I don't see anything broken other than just physically broken, and like most of things here are just physically broken. There's a whole pile of broken plastic parts from various places, and the reason for that is the person who put this in the package figured that 20-pound device can be secured just by the box itself and some paper around it. So that was unfortunate, because most of the damage that I see here was done during shipping. I'll need to somehow make this straight again. I'm not sure how. I guess I'll just take 2x2 and just try working with a hammer and a 2x2, and I'll see if that will work. It does have active cooling fan, so that's great. And our big transformer, it's roughly it's not much bigger than the other one. Well, not much bigger actually, transistor or transformer considered, this one's a lot bigger. Too bad they don't actually label them. The other one was labeled, but none of them had. Yeah, this one is labeled as well, but none of them say what is the VA on the output. 25 volts, 5 volts, 8 volts, 21, 9. So all kinds of voltages, but no actual power. But actually, to calculate it, you can just measure this actual size of the transformer, and you can on the size of the wire that is being used on the primary and secondary, and having that, you can roughly assess the maximum power output of the transformer, which is not something that I'm very much interested. I will connect resistors and we'll see if I'm actually getting high power, but this very well could be 1 kilowatt. It definitely looks like it. All right, I'll test it and let's see what else is broken. All right, so it is working. voltage shouldn't be too high here. No, nothing should be getting warm because there's no, I didn't connect anything on the load, so there's completely no load on it. But it did turn on. Bluetooth seems to be working. Let's see if we can find the device. Okay, so it appears to be BTRY, labeled BTRY, and I'm not sure what's up with that, but it looks like it's connected. Let's start with this signal generator and go from there. Okay, we have a working amplifier with Bluetooth and everything. So I heard the relays actually turn on, so I could connect speakers and just give it a test. What are we on? 21. And if I get the volume very high up, let's see, does it heat up? Not really. Let's get the volume all the way up, and the fan is spinning. And when you get the volume down, the fan turns off. So it's actually not controlled by the actual temperature of the heatsink. Just the volume, I guess. But looks like it's working. There's nothing wrong other than how it was shipped. Although it was advertised as something's rattling inside, but I bet there was a lot less rattling inside before that last shipping. All right, now let's see if we can fix some other stuff that is wrong with it. I'll probably block this over here because I don't think I'll be able to get the CD to work, and even if I do, how am I gonna test it? Let's turn off the buckle up, Wyoming. Okay, I'm buckled up. Get out of here. Okay. All right. This will be working. Beautiful. Alrighty. So here's the issue, or maybe perhaps it's not an issue. But first, let's see how it's built. We have 4 transistors that drive speakers. These are A1941 and C5198, 78 and 79 regulators, linear regulators on both sides over here, stabilizing positive 12, negative 12, 5 volts, and I don't know what the fourth one is for, but I think it's also 7805. The heart of the device is this chip over here. This chip is PT3214. This is 4-input audio processor. You can control treble, volume, bass, all that stuff, and obviously switch between 4 inputs. And we happen to have 4 inputs over here, and plus 1 input, which is Bluetooth. But Bluetooth is kind of weird. not in like in other Pyle devices where the device is constantly connected to Bluetooth and you just kind of switch between Bluetooth or input or radio or what have you. This one actually uses Bluetooth interchangeably, I think, with radio tuner. And why do I think that? Because if you switch to Bluetooth, you can still hear a little bit of radio playing in the speaker. So it doesn't really disable the radio, it just switches the input. And that's when it starts connecting. Our Bluetooth module is right here, soldered antenna, and routed routed externally to routed to the external port, so you can use external antenna. So as per usual with Pyle devices, everything is really simple. This one is particularly very modular, which I love. So we have the output module, which just contains the electro switches or the relays, the magnetic relays, some coils, transistors, that kind of stuff, and that allows the device to turn on and off the load. And we have ability to connect 4 speakers, 2 pairs. And this is DVD encoder or decoder. Also it supports optic output, video, all that stuff. Everything's contained here, and that's connected to the DVD reader. Our FM and AM tuner, nothing special here. Interestingly, this is kind of connected with the wrong connector, or not connector designed for this. And of course we have inputs in the back, like MP3 and auxiliary coming from the back. On others, the auxiliary comes from it hooks up in the front. Now, since we know how it works, oh, by the way, almost forgot, this is very important. So we have MCU over here. That MCU, it unfortunately does not have any markings on the chip. There's no markings, so they were never put there or removed, probably removed for whatever reason. If I had to guess, this is Atmel microcontroller. Based on the packaging and where the power comes in, and the fact that it's the crystal next to it is 6 megahertz. So I would say this is Atmel microcontroller. Why do we need that microcontroller? Because our heart is controlled by a I2C rail. So basically, to control this chip, you need to send it or data on I2C rail. So that's what we need the microcontroller for. Now the problem, it's not a huge problem, but there's a noticeable hiss in the speakers, the high pass filtered speakers. That hiss is dependent on how you control the treble. If you pull the treble all the way down, then it's barely noticeable. If you get the gain of like 15, I think that's the limit, then it's very much noticeable. So it's basically high pitch, according to my oscilloscope, somewhere between 6 and 30 kilohertz. It's not stable. It's kind of like, it's a hiss. It's not a stable frequency. So it's not a hum. It doesn't come from these from the power. It doesn't come from the transformer. It's a hiss, much higher frequency. If it was coming from the transformer, we would have 60 hertz. That would be a hum. So that would be easy to eliminate. But this is hiss. Hiss usually comes from digital electronics when they're not properly screened or filtered or isolated. So I was considering recapping these, but as I said, since it's not 60 Hertz, this is not the hum, so these caps will not help. Then I considered replacing these by the MCU. I tested them, they all test fine. I don't think there's much I can do over there. I checked all the filter input output capacitors, all good. The hiss is not, it doesn't react to the volume. On these, like these cheap amplifiers, if you get the volume all the way up, then the hiss from the speakers is loud. If you turn it down, it's much lower. With this one, it's completely unreactive to the volume, regardless whether it's 1% volume or 99% volume. The hiss is exact same, which means if you're listening to the music on like 10%, you can't hear that hiss. Only when you're listening very, very quiet and you're close to the speakers. But you can also reduce the treble gain, and that also helps a lot. I tried isolating the problem, unhooking everything, and finally, since it's not related to volume or anything, I finally decided that it's coming from that ISP. It is, sorry, the I2C. So there's nothing I can do with that. I2C goes through here under this heatsink and goes way around here to these cables over there and to the chip. So it's just routed in a weird way that you can't get rid of that hiss. And you could if you put this control unit and this chip also on the separate module, separate from the amplification. Then it wouldn't be there. But it's not the problem of amplification because it's just coming from that chip. So there's not much I can do with this. It is not very much noticeable, and since it's a 1 kilowatt power on the power amplifier, you kind of expect it to kind of connect big speakers to it and play loud music from it. So that this tiny hiss would not even be noticeable by most users. The reason I noticed it because I have the speakers right next to me, and obviously I was testing it on 1% volume, or volume set to 1, the minimum volume. That's when you can actually hear it. Other than that, the amplifier is working very well. I'm not too happy with the radio. I think there might be, not sure, but I would have to test it with the real antenna. But hooking up antenna doesn't really increase the range of it, so I'm not sure. But by antenna, I mean the piece of wire that I was connecting, not actual calibrated antenna. So that could be it. Although on the PDA6BU, even if I connect the wire, it still picks up great. This one also picks up radio stations and everything, but even if I connect the antenna, I don't see any difference. So there might be some issue over here, not that I've seen over here. I also checked the caps and everything seems to be good. So basically nothing wrong with this device as far as I'm concerned. Overall, pretty good. My 700 watt speakers are pretty much, I never tested it on full volume because the membrane is swinging so much that I'm just afraid I'm gonna blow my speakers. And if the real output power of this is 1 kilowatt per channel, which I doubt, but if that be the case, then this device is perfectly capable of blowing my speakers. But it's got a lot of power. The sound is relatively clean. There's very little distortion on the sine waves throughout the frequency, the frequency range. And that's it. That's pretty much it. That's our Pyle PD1000BA. Very nice machine. Very nice machine. I think new it cost about $200. There's not much inside, as you can see, and everything is made relatively well. Considering that it's Pyle, there's very few things held together with hot glue, like this screen over here. On PDA-6BU, it's held by hot glue. Here it's actually screwed in by 2 screws over here. So it's much better construction overall. It what do you call it? The fan, as I thought before, it was only controlled by the volume, but there is actually some feedback, some thermal feedback. So even if you're listening to it on low power, the fan is going to turn on eventually when it gets hot enough, and it turns on for a little while, then turns off. I'm not too crazy about the arrangement over here, because that hot air, maybe like this, yeah. So that hot air from over here is blowing through here and onto MCU, on Bluetooth module, capacitors, the mains moving capacitors. So I'm not too crazy about this design. I would kind of imagine that this would be that the fan would be blowing outwards, not inward, and otherwise, if it blows inward, I would expect that there's a vent basically blowing that hot air outside of the chassis rather than inside. And so that's kind of a weird thing about it, but it's all the voltages are actually stabilized properly, unlike the PDA-6BU. So this is definitely a better amplifier, much better construction, much more capabilities, and it's kind of designed to play loud. When you set it to like 20, it goes up to, the volume goes up to about 65, something like that. So if you set it at 20, that's when you start getting some power indication that there is the -20 dB, right? So it's not designed for playing quiet music. That's why probably that hiss, no one was bothered by that hiss, because this is not the device that you listen to on headphones. Although you can connect headphones, and the same thing, the hiss is there the same way, regardless of volume level. It's just there. So maybe not the best device for listening to anything on headphones, but other than that, it's a beautiful construction. I love how resourceful they were, and if anything other than the MCU breaks here, it's completely repairable. If the MCU breaks, sorry, the device can be thrown in the trash, unless the Pyle actually supplies the code for this MCU. Because even if you replace the chip itself, then you don't have the software in it, so it's still not going to work. All right, that is the PD1000BA Pyle, USA.com, and I thank you very much for watching, and I shall see you in the next one.